Okay, so here are our notes for today. So, uh, trigonometry day 2, we're talking about slanty hills. And we started off with this warm up where we got x over 2 equals 3 plus, plus x over 5. So, one way to solve this would be to cross multiply, and then you would get 5x equals 2 times 3 plus x. Then I could do distributive property with the 2, and then we end up with 5x equals 2 times 3 is 6, and 2 times x is 2x. And then the next step, we're going to solve for x, we have to subtract 2x on both sides. And when we do that, 2x minus 2x, that's going to go away. And then I end up with 5x minus 2x is going to give me 3x. So I get 3x equals 6. Divide both sides by 3, we get x equals 2. Okay, so now let's talk about what we've been talking about for the last few days. All similar right triangles have the same ratios of sides. So what does that mean? So here I've got 3 similar triangles, and I measured it with my ruler, and I measured this to be 2.5 by 1 centimeter. I measured this to be 5 centimeters by 2, and I measured this to be 7.5 centimeters by 3. And if I take all of these measurements, remember we're focusing with opposite side over the adjacent side. So if I'm using a calculator, I can see that the opposite side, which is 1 divided by 2.5, we end up getting 0.4. Okay? And then if I take this opposite side and divide it by the adjacent side, we get, so 2 divided by 5. Once again, we have the same ratio of 0.4. Okay, and here we have the same ratio of 0.4. And also, if I get the same ratio here. So I've got 3 divided by 7.5, and I get the same ratio of 0.4. So what's important to understand is whenever the ratios are the same, here I've got 1 divided by 2.5, I get this ratio here. I have 2 divided by 5, I get the same ratio here. I have 3 divided by 7.5, I get the same ratio here. Whenever my decimal ratio is the same, then my triangles will be the same. And you can even see, because I carefully measured these triangles do look the same, don't they? And so if I use my protractor and measure this angle, I'm going to find out that this angle is 21.8 degrees. So the key here to remember is whenever the ratio is 0.4, no matter how small or how big the triangle is, this angle here will be 21.8 degrees. Now let's look at some other examples to demonstrate the same thing. You may have seen triangles similar to this before. Here the opposite side is 2 and the adjacent side is 2. Here the opposite side is 3 and the adjacent side is 3. Here the opposite side is 4 and the adjacent side is 4. Just from the naked eye, these triangles all look the same, don't they? And this ratio of 2 over 2 is equal to 1. Here I've got a ratio of 3 over 3, which is equal to 1. And here I've got a ratio of 4 over 4, which is equal to 1. And whenever my ratio is 1, I will always have a 45-degree angle. You might want to hit pause and copy this down. Okay, similarly, here I've got my opposite side is 2.5 and the adjacent side is 1. 2.5 and the adjacent side is 1. Here I've got my opposite side of 5 and the adjacent side is 2. And here I've got my opposite side of 7.5 and the adjacent side is 3. So let's get a calculator out. Well, 2.5 divided by 1 is 2.5. I know you're shocked. Okay, now let's look at this other example here. 5 divided by 2 is also 2.5, right? And what about this here? 7.5 divided by 3 gives me also 2.5. So whenever my opposite side is and divided by the adjacent side, whenever that's equal to 2.5, then these triangles will be similar. So that said, don't these triangles even look the same? I very carefully measured these so that they would have these lengths, and you can tell that these triangles all look similar. And whenever you've got this ratio of 2.5 with the opposite over the adjacent, you will end up with a 68.2 degree angle with the reference angle. Okay, you may want to watch this a couple of times, and hopefully this will help. Something lastly, if this is 68.2, notice this reference is 2.5 over 1. On the previous page, we had 1 over 2.5. This angle here was 21.8. This angle here was 68.2. What is 68.2 plus 28.8? Dun, 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 dun. Wait. Oops. 21.8 plus 68.2 is 90 degrees. Doesn't it make sense that if this is 2.5 over 1 and this is 1 over 2.5, that I would have two angles that add up to 90 degrees? More to come. This is just the beginning.